Okay, so this is a kinetics question. It's AQA A-level chemistry. And there are three parts to it, A, B and C. I'm going to recommend that you have a go at A by pausing the video, try and put your answer down on paper, then move on and do B, and then move on and do C. Should be pointed out, B might be quite difficult because you are adding on to the graph, but you can think about where you would put the answers and how you would do it and describe it in that way. So this is part A, part B, and part C. The important thing with this question is that it's asking how a catalyst works. It's not asking what a catalyst is, and they are two very different questions with very different answers. How a catalyst works, we will say that it provides an alternative reaction pathway and it lowers the activation energy. Now compare that to definition of a catalyst, which is something that speeds up the rate of a reaction without getting used up in the reaction. Very easy to get those confused, so you've got to make the effort to not do that. Moving on to the next question, and you're adding lines onto the graph. Now, as I suggested earlier on, you could predict what it would look like and describe it if you don't have the question to hand. First thing to look at with experiment 2, and I've not numbered it, I've used colour coding, is that we are using a powder for the catalyst, which is a greater surface area. So we know it's going to be a faster rate of reaction, so the line starts off steeper. However, my concentration of H2O2 is identical to 1 and my volume is identical. So I'm going to make the same volume of oxygen. So to get the mark, it has to be steeper, but it has to finish at the same height. When I compare that to green, which is back to lumps, so it's not faster due to surface area, we've got half the concentration. So we know that the concentration, lower concentration lowers the rate, so it's a less steep line. But also if I halve the concentration, I've got half the amount of H2O2 in a given volume. So I'm only going to make half the volume of O2. So it has to finish at half height. And finally, part C. Explain in terms of collision theory the effect of increasing concentration of hydrogen peroxide on the rate of reaction. So it's a specific one about hydrogen peroxide, but actually a very generic question. There are more particles in a given volume, and so there are more frequent successful collisions.